Hello and welcome to the Daily Space for today, Monday, October 5th, 2020. I'm Dr. Pamela Gay, and I am here to put science in your brain. A week ago today, our show abruptly went dark. One of our core team members, Tim Hawkins, who went by Paranor001 online, had passed away rather suddenly. His health had never been good, and natural causes caught up with him, well, as they can catch up with any of us. For a long time, Tim had been someone who I talked with almost every day. He was the first person to comment when audio levels were off and the first to ask, "Are you okay?" when he realized one of us was having an off day. This community is made of a myriad of people who are striving to do more, to be more, and grow beyond who they are today to become something better. Tim personified this spirit of striving more than anyone else. While struggling with his own demons, he always found a way to try and protect us from the dark corners of Twitch and Discord communities. We are all imperfect beings. Paranor001 described himself as a madman without a blue box. Over time, he became family to many of us. He was always open to a game of Ticket to Ride and went from one of the worst players to one of the best. He was always here for Minecraft and became a streamer in his own right as he shared this game he loved. One of the last things he and I worked on were plans to do a Minecraft solar system build during this year's Hangout-a-thon. This was Tim's idea, and we're going to go forward with this plan and dedicate both the event and the build to him. As a former actor, Tim would have wanted the show to go on. And after a week of struggling with our grief, the show will go on. In today's space news, a consortium of major observatories, including the Very Large Telescope, Large Binocular Telescope, and Keck, have been used to observe a massive structure in the early universe, consisting of a central massive galaxy surrounded by six smaller but still large galaxies. This system contains a central supermassive black hole that is roughly 1 billion solar masses in size. Light from this object has been traveling toward us since the universe was less than 1 billion years old. And the existence of such a large supermassive black hole at such an early time in our universe confirms that massive systems formed rapidly in the early universe. According to lead author Marco Mignali, the research was mainly driven by the desire to understand some of the most challenging astronomical objects, supermassive black holes in the early universe. These are extreme systems, and to date, we have no good explanation for their existence. This work appears in the latest issue of Astronomy and Astrophysics. Our finding lends support to the idea that the most distant and massive black holes form and grow with massive dark matter halos in large-scale structures, and that the absence of earlier detections of such structures was likely due to observational limitations, says Colin Norman of Johns Hopkins University, a co-author on this study. The next generation of massive telescopes in the James Webb Space Telescope, if it launches, will provide needed insights on these systems to help theorists understand how the large early systems formed basically one at a time through an all-in process, while other systems, it turns out, formed slowly through merger-related processes. Until these massive new telescopes are online, we look forward to more discoveries like this, of the most extreme and rare systems, which are already visible to today's telescopes. In other news of the rare and extreme, the High Z supernova search team and the supernova H0 for the equation of states, or SHOES team, have released a remarkable time-lapse video of supernova 2018 GV. This Type 1a supernova is completely average and was generated by the explosion of a white dwarf star that had mass dumped onto its surface from a companion star. This video shows us how over 1 year, this system faded as the energy and shock waves of the explosion radiated through surrounding material and expanded and faded. Let's watch this one more time. In our final story of the day, the extraordinary gravity instrument on the Very Large Telescope has allowed the direct imaging of 2 planets orbiting around the star Beta Pictoris. Dubbed Beta Pic C, this glint of light was confirmed as a planet using additional radial velocity measurements that could measure the planet's gravitational effects on its host star. With this data, researchers can measure the planet's mass and luminosity, and by making assumptions about the planet's composition, they can estimate its size as well. So far, it appears that inner world C is 8 times the mass of Jupiter. It is also 6 times fainter than its larger, more distant sibling, which orbits every 28 years and hasn't been known long enough for us to measure its mass yet. When that world finishes its orbit and we can tell you its details, we'll bring them to you right here on the Daily Space. But for now, that ends today's episode. Today's episode was written by me, Dr. Pamela Gay. Engineering will be provided by Ali Pelfrey, and web content is produced by Beth Johnson. You can get a complete transcript, show notes, and see images related to each of our stories at our website, dailyspace.org. We are a production of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are here thanks to the generous contributions of people like you. This October 24th and 25th, we're going to be holding a 36-hour-long hangout-a-thon to raise funds to cover our costs during the 2021 fiscal year. To learn more and donate today, please visit our website, CosmoQuest.org.